Okay, I'm going to go through a pretty detailed overview of the UI for ForgeUI as far as text to image goes. I'm not going to go into absolutely everything, and I'm not going to go into a lot of specific detail about some of these things, but this is a pretty long video because there's a lot of options here. So hopefully this helps you out. Okay, so we're going to go over the basic UI and settings and information about ForgeUI, just to give you an overview of kind of what each option roughly is and kind of what they do without diving too deep into the weeds. We're basically just going to sort of go relatively quickly through this. Okay, so starting in the top left, this UI option here has to do with the ability to run the different models of Stable Diffusion like SD1.5, SDXL, and Flux. Now, depending on what you're running on a daily basis, you probably are only going to stay in one of these most of the time. But either way, you do kind of want to be able to switch this because it affects the overall settings of what is available as options. You could just go with all, but generally speaking, I would say you should click whatever you're currently using just so you don't have any extraneous stuff on the screen. So I'm going to be using Excel for these examples for now. And so I'm going to select Excel. Now, the next one is checkpoint. Now, this is kind of like the selection for which of the checkpoints you have. Checkpoints are fine tunes of overall models to make them either better at something or at least stylistically different in some way, whether that be they can make certain types of images, certain styles of images, or even just they happen to be more well trained, so they just have better outputs, you know, like hands being better, textures being better, details being better. A lot of different options, and generally speaking, you'll find a couple good checkpoints that you like for whatever you're trying to accomplish, and you'll want to use those for most things. So it's a good idea to just kind of look through these, figure out what you think is best for you, but also just test a lot of them. They can be pretty large files sometimes, so depending on how much, you know, download bandwidth / capacity you have as far as on your computer, or just how much you're allowed on your data limits. You want to be a little bit frugal with just, you don't want to download absolutely everything, because they're roughly 2 to 4 gigs for SD1.5, about 6 gigs for most, 6 to 7 gigs for most SDXL checkpoints. And with Flux, it can vary widely from 6 gigs to over 20 gigs, depending on a lot of factors. All right, so the next option here is VE, or text encoder. This has a lot of variability depending on whether you're using Flux or not. If you're not using Flux, then generally speaking, you're going to have one thing in here. So, you know, you have, for instance, I'm going to quickly switch this. I hit SD, so I'm going to be SD1.5. I can go in here and click this, and I've got some options here. And generally speaking, there's a VE for SD1.5, a VE for SDXL, and then there's a bunch of other stuff for Flux that I'll go over in a different video. But essentially for Flux, it would look, generally speaking, something like this. You probably want those 3. There is a little bit of variation here, but you probably want those 3 for any Flux that you're doing. We're going to do some SDXL, so I'm going to go back to SDXL VE and back to SDXL here. Now, VEs are important because they kind of affect how an image comes out, because it has to do with the image getting decoded kind of as the last stage of generation, depending on the model and depending on whether there has been a VE baked into the checkpoint, because that's something you can do. And in some cases, using a VE in your setup will either be ignored or override. Again, this is a lot of testing, but generally speaking, if you have an image that looks like this, it's probably because you don't have the right VE or don't have a VE on at all. This next option, diffusion in low bits, is kind of like a fix for not having enough VRAM, or like your system is not good enough or strong enough or to sort of run what you want to be able to run. And this is kind of a way to sort of override that or work around it. Most of the time, you're probably going to want on automatic. There are some cases with Flux. There's a lot of different cases. There will always be different things. Like there's always going to be caveats to all these things that I talk about. But generally speaking, you're going to want on automatic, or maybe this one, automatic FP16 LoRa, because sometimes with certain Flux LoRas, they won't work if you don't have that. Essentially, these 2 options, a lot of times troubleshooting is the best option. Try different options till something works. Okay, moving on. Now, there are a bunch of tabs here, but we're only really going to worry about text to image today. And mostly because text image is probably what you're going to be wanting to do most of the time. There's a use for all of these other options, some more than others, but text image is kind of our like core feature. Prompt is pretty self-explanatory. You put in here what you want to see. Negative prompt is you put in here what you don't want to see. Now, SD 1.5 and SDXL have prompt and negative prompt because of the way that those models were made. They need it, generally speaking. You can get away without using it sometimes, and sometimes you can't. It's just kind of variation. Flux, though, you can kind of see how I can't click on the negative prompt here. Generally speaking, Flux does not need or want negative prompting. And then we've got a bunch of more tabs again. We've got generation, textual inversion, checkpoints, and LoRa. Now, mostly, we're not going to worry about textual inversion or checkpoints hardly at all. LoRa is probably our most commonly used tab other than generation when we're doing text image. I'll go over LoRa at a later point when we're talking about LoRa's, but essentially, we're mostly going to stay in generation. Sampling method is something that is, generally speaking, less important than most of the other settings here. Same thing with schedule type. Sampling method and schedule type are relatively unimportant to the effects they have on the images. Now, that's not to say that they don't have an effect, or in some cases can't have a drastic effect, but you could generate an image with Euler A and generate an image with DPM++3M SDE, and from a sort of casual look at the image, there may not be a significantly obvious difference between those two. And as such, you mostly are going to either want to look at the suggested settings for any checkpoint you're using. Usually whenever you download the checkpoint from like Civet AI, there will most cases be suggested settings, or you can look at their sample images or images that people made with that thing and look at what settings they use to kind of get a gauge of what might work well. But one of the more fun and interesting things about AI art is you kind of want to try a lot of different things. Now, I'm not saying you should go in and generate an image with every single one of these things to see like what works and what doesn't work or what works well. I'm just saying you will probably want to test several of these and kind of get a sense for if you like it or not. Now, there will consistently be the case that there will be some checkpoints that just don't work very well with certain sampling methods. So you don't want to just be like, I'm always going to use one. Though if you were going to use one, depending on your art style, if you were going to use one, Euler A is a pretty strong one, and DPM++2M SDE is also a pretty strong one. You pretty much can't go wrong with those two. Pretty much any model you try, one of those is going to work decently. Maybe not the best, maybe not the worst, but somewhere in the middle, most likely. And in some cases, it's going to be the best option, or, you know, nearly indistinguishably different. Next option is schedule type. And this is, again, one of those things that can be a very minor, almost completely unknowable difference, or it can be pretty significant. This is a very rough example, but generally speaking, automatic is a strong option. There's a little bit to be said that if you're trying to go for realism, Keras and Exponential might be a good option. Sometimes simple can be good for Euler A. Beta can be good for Euler A. But honestly, this is again kind of like the sampling method where a bunch of these options are potentially viable, and in some cases you will never notice a difference. So depending on the level of specificity and how much you want to control your image output, some of these options are just going to be standard, like leave it at this and that's it. But again, testing is always a good option. Test a bunch of different things, see what looks better. It's pretty much a guaranteed fix for most problems. If something doesn't look good, try a different option first. If it doesn't work again, then do research potentially. Sampling steps. Sampling steps can be a little tricky because the magnitude of sampling steps can vary significantly. So for instance, there are models like lightning models or turbo models, or sometimes not even labeled as those kind of models, that just use way less steps. Sometimes it'll be called fast or something like that. And so they might say something like use 4 steps. Generally speaking, if you use 4 steps on a lot of models, it won't even generate anything. It'll be a blob or, you know, grayscale or something. So as a general rule, I would say right around 20 to 30 is a pretty good range. All the way up to 40 is pretty decent. I wouldn't go much above 40 unless you have a reason to, which is a model or a checkpoint very heavily suggests that you go above 40, like you go to like something like 50 or 60 or something like that. But you very rarely see anything that says higher than 50 because you don't really get much of a benefit in most cases. This again depends on your sampling method and your schedule type for all of these things, because every time you tweak any one of these settings, everything else is, independent from that. So like from a sort of general testing philosophy, which is pretty much obvious, but just general testing philosophy, change one thing at a time. So I wouldn't want to go down to 20 steps and change my sampling method in the same test, right? Because now I've changed this, and who knows what is having the bigger effect, right? So sampling steps, 20 to 40 is probably a strong like band of quality. Hitting about 30 for most things is going to work pretty good, unless you happen to have one of those models that it behaves in a way where way less steps is better. That is, in some cases, something you just have to find out via testing, but usually you'll be able to find those settings when someone's posted a checkpoint. They'll have those settings and suggest what you do, right? They're technically more sampling steps generally means more detail, but that is not 100% the case all the time, because obviously, a 4-step model, if it's only got 4 steps, it'll be super undetailed. That's just not the case if a checkpoint is made for that, right? So more generally means more detail, but more detail doesn't always mean a good thing either. Because like if you think about it from like a perspective of, let's say you're trying to make a realistic image of a person or even a building, more detail sometimes results in artifacts, or oftentimes it results in artifacts that just look wrong. Sometimes a low sampling step is better, but below a certain threshold, it just won't really generate correctly in most cases, depending on the model. One of the things that you will tweak really only when you are doing a specific checkpoint change, right? So like if I switch checkpoints and it's like, oh, okay, I have to do, this is an 8-step checkpoint. This is where I stay. Now, there is a little bit to be said for changing a couple steps one way or the other to sort of affect the way the model generates. Okay, we're going to skip over high-res fix and refiner. For now, we're going to go width and height. This one is probably the most straightforward of the options here. The width of your image, the height of your image. This is a quick little button here for switching your from vertical to horizontal, landscape to portrait, whatever you want to call it. Batch count is how many images it will generate with the same settings you currently have. And you change this to 4, instead of generating 1 image at a time, you're generating 4 images at a time. If you change this to 4, you are generating 1 image at a time 4 times. Sometimes this is important, sometimes it's not. Batch counts can be good for like testing, batch size can be good for testing. All this stuff can vary, but essentially speaking, most of the time you're going to leave this at 1. You're almost always going to leave this at 1. And other than like wanting to sort of generate a bunch of images while you step away or something like that, that's really the only time I regularly use this, where I'm like, oh, I have some stuff set up that I want to see what happens. I'm gonna generate 10 images, right? I'm gonna generate 10 images. I'm gonna step away for a minute and then come back and it'll be done. Something like that. The CFG scale, classifier free guidance scale. How strongly the image should conform to prompt. Lower values produce more creative results. This is maybe technically true, but from a like actively used case, like how you are using your generations and how you use CFG, that's not really how it works out to be. Mostly because every checkpoint is very different. And so if a checkpoint suggests 7 as the CFG, that might not necessarily be what you want, because CFG is probably the most varied thing when it comes to how your system will duplicate an image. This can get very complicated because you'll look at a checkpoint, you'll look at someone's images and they look really good, and you'll be like, oh, they use CFG scale 7. And then you'll generate an image and you're like, well, my image doesn't look like their image. What's going on? And assuming it's not the VE, it's probably your CFG scale, because your CFG scale can affect a lot more than how strongly the image should conform to the prompt. Lower values produce more creative results. That's just not really apparent when you're actually generating images. And mostly what it seems to do is change the visual look of images in a way that often is bad. Like it's like, oh, this looks like a bad image, or this looks like a good image. And it's a lot harder to notice the actual how closely something follows your prompt, because prompting is not an exact science, right? You know, a blue dog, and change your CF scale by 5 points, which is a lot for CFG, it's going to be a blue dog still, right? And again, the more intricate your prompt, the more it'll affect. But generally speaking, CFG scale is one of those things where a thing you're going to move up and down, but it's going to have bands, kind of like sampling steps, where there will be certain checkpoints where they want you to have something like 1.5 or 2.5. And then there's going to be the vast majority of them that are going to say something like 7. 7 is a solid number that a lot of people use. I find in my own testing that oftentimes a checkpoint that says 7, I get much better results at like 4. Sometimes I get better results at 10. This also has a lot to do with the kind of image you're making, right? This is not 100% just true across the board, but generally speaking, if you're trying to make a more realistic image, CFG scale being lower oftentimes helps, because it seems to be the case that the lower the CFG scale is, the more likely it is to kind of make a more natural image, like a photo or something like that, right? So like, I'm not sure how you would straight up calculate this, but there would be, generally speaking, the case that if a CFG scale is lower, it's going to ignore your prompt more, which means it's going to kind of go with its own choices. That oftentimes results in a better looking realistic image. But again, it's not a hard and fast rule. There are some realistic image things that work pretty well and sometimes better at like higher CFGs, but usually it's like 7 at the max for realistic. Whereas things like anime or cartoon or, you know, digital art, fantasy art kind of checkpoints, they might be good at like 8 or 9 or 10. But even then, you know, I'm often never putting, I cannot think of an image that I've ever made that was good that had a CFG scale higher than 10, because it just does weird things to images that usually result in not a good look. Now there are scenarios where maybe that would be what you want, right? Like certain types of art styles or whatever, and it can just be the perfect option. But general scale, you're going to say 10 or lower. 7 is a solid choice. A little bit lower than 7 might be better. Some checkpoints will want real low, like 1, 2, that kind of stuff. It's kind of like sampling steps in that way as well. Seed is pretty straightforward. -1 in this case is random, right? So here's a little thingy that right here, if I click this, that randomizes the seed. So if I could go like, I could use that seed right there and make an image with it. Or I could hit randomize and make an image, and it'll just give me some randomly generated seed. Same thing with, I could do 1 and then 2, 3, 4. 0 won't really work. -1 is what you want for random. Another option is, once you've already generated an image and you're like, oh, I really like that image, I want to do it again, but tweak the settings a little bit, or this is where high res fix comes in, or use the same image. Clicking this button, reuse seed from last generation, mostly useful if it was randomized, right? Now again, this is going to randomize it. If I had, you know, 456 in here, I wouldn't obviously need to ever use this, but 456 is just a random number, right? And the way that random generation works means that if you leave the seed the same and change only your prompt, generally speaking, your image will be more similar than less similar to what it was before. So you can like kind of fine tune your image by keeping the seed the same and changing prompts a little bit. But I generally find it easier or faster depending on how you're wanting to do what you're doing, right? Because like random can be good and bad, and it's like a double-edged sword. I generally find it easier to tweak the prompt, use random seed generation, generate multiple times till you get a good result, because sometimes you just get a bad seed or a good seed. There's no way to know if you had a good or a bad seed based on one generation. I would generally say randomizing until you have something you really like, and then maybe using that again to change it. Now, another thing you can do is reuse a seed. So for instance, say there was a seed like this from the image I just generated. Now, since that seed is there, the image that I'll create will be identical to the last image. And so if I go to this thing right here, high res fix, I can go in and change or switch out the size of the image. If I look at this, it says from 896 by 1152 to 1792 by 2304, because it's upscaling it 2 times, right? It's like twice as big. It's less demanding on your system to do high res fix. It is easier to generate an image at this resolution and then high res fix it up to a bigger one, which is kind of just like upscaling it. It's basically just upscaling it. So there are negatives to this, obviously, but generally speaking, this is a good option. This is another thing that's going to vary a lot, but upscalers, there's a bunch of different ones, and they have a lot of different good uses or bad uses. I really like this one, 8Txt2Img Superscale 150,000G. I can find a link for that and put it in the information. Other good ones are like these ESR-Jan ones. Even like a lot of these are good or fine for most things, but you kind of want to test a few and figure out which one works best for your workflow / output, right? Because like I like this NMKD Superscale one because it works pretty good for realistic images. But I mean, this one right here says Anime 6B. Now that doesn't just be like, oh, this is the best one for anime, but it's not bad for anime or, you know, that kind of style of art. But all of these are potentially usable and will oftentimes come out with a pretty good image. They just have good and bad things about them, right? So it's all variable. High res steps. This one it's a little bit dependent on the checkpoint, but generally speaking, 0 means it will match the sampling steps you're using, which means so 30 sampling steps, 30 high res steps. Most of the time, pretty much all of the time, you do not need as many high res steps as you have sampling steps. I would say like 1/3, 1/2, 1/4 is a pretty good option. So I'm going to go something like 10 for high res steps to high res scale. High res CFG scale. This one probably in most cases, you're going to want to keep the same as whatever you're using, right? So like if your regular CFG scale is 5, your high res CFG scale should probably be 5 also, and so on. Upscale by amount. This is pretty much only dependent on your system and your denoising strength. If you wanted to upscale by 4, that's going to take quite a while if you have not like a ton of VRAM. In some cases, it might literally be too like much VRAM and you might not be able to do it, right? I'm running on an 8 gig VRAM system and I usually don't go above 2, and often I aim for lower than 2 because the results are pretty good. And if you want to upscale again later, you generally can without too much issues. I would shoot for like, you know, whatever makes sense with what your resolution is. You know, so like for instance, 896 1152 doesn't really make much sense for a lot of like how it would scale up. But if I was gonna be like, oh, I want to make a desktop wallpaper, right? Then something like 1280 by 720 with a upscale 1.5, that gives me 1920 by 1080. That's a pretty good size for a desktop wallpaper, right? And then theoretically I could upscale it later to like 4K or something like that if I wanted to, but this is a pretty good option. 1280 by 720 works pretty well with SDXL. Denoising strength. This one is pretty important. Determines how little respect the algorithm should have for images content. At 0, nothing will change, and at 1, you'll get an unrelated image. With a value below 1.0, processing will take less steps in the sampling steps, slider specifics. Okay, so this is probably the setting that will affect your final product the most when it comes to high res fix. You know, the upscaler can definitely have a big effect. The high res steps, if it's super low, it can matter, but it won't really matter. The upscale amount doesn't matter nearly as much. And honestly, the high res CFG scale probably doesn't matter as much. But denoising strength can be a lot. And just like this says, if I go all the way up here, I'll get a different image. It'll be based off of the prompt, but it'll be a different image. And oftentimes it won't be a very good image because it'll kind of be doing its own thing. And it'll be trying to generate an image at a much bigger scale, which means it'll be harder for your system, all kinds of stuff like that. So I would say that you don't generally want to go below 0.2, because below 0.15, it probably won't have any effect at all. It'll just upscale the image, which sounds okay, except that a lot of times high-res fix can kind of smooth out some rough patches, right? It can make the image look better than the baseline. And so you want it to do a little bit of work on the image, especially because it's expanding and it's making it bigger, which will cause, not pixelation, because that's not really how it works, but like it'll cause a similar effect to what happens when you upscale an image. Like it sort of gets worse, blurry, artifacts, whatever, right? And denoising will kind of fix some of that. I like 0.4. 0.4 is pretty good. You can definitely go with like 0.3 or 0.5, but I wouldn't go much above 0.5 most of the time. You can sometimes get some really good results with 0.7, but it will lose a lot of what made the original image good. Now, if you're just generating full bore with high-res fix on, maybe you don't care about that. So 0.4 is pretty good. And I would say, again, generally speaking, you don't want to go 0.5, and you probably don't want to go below 0.3, but you definitely don't want to go too low or too high. So 0.4, I like 0.4. We're going to pretty much completely ignore Refiner, other than to say that Refiner is no longer needed in most cases. There was a point with SDXL where you needed a refiner to make it look good. That's basically the past now. It can be used, and maybe you'll get really good results with it, but I gotta be honest, I basically do not use Refiner and have not used Refiner since the early days of SDXL. All right, that was a pretty long video, so if you're here at the end, thanks for sticking with it. Hopefully there was some information in there that helped you out. Thanks for watching. It'd be really cool if you liked and subscribed. It helps a lot with discoverability. Thank you.